Hello and welcome to an episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Josh Matthews. He is a longtime contributor at Servo. Welcome, Josh.
Hello there. Thank you.
Yeah, we were just talking before the show about kind of your history with Servo. Do you mind to repeat?
My pleasure. Servo for me is really special because I got involved in it in 2012 when I was hired full-time by Mozilla. And Servo at the time was basically just an idea. There was enough Rust code written that could parse HTML and turn it into rectangles on the screen, just like solid color rectangles, no text or anything. And they handed it to me when I joined and said, okay, now make this run JavaScript. And that was sort of like the beginning of, figuring out what is actually like a web engine. What are the different pieces that you need to actually write when you're starting from scratch like that? And we were doing it in this language that was evolving at the same time, which was it was really fascinating at that time, where Servo in its first few years was being used as like a guiding light for Rust to help figure out, are we making the right decisions around this language in order to, be able to build something as complex as a web browser. So there was a lot going on at the time. I've been involved with Servo since that initial commit in 2012, and I'm still involved today and helping keep the lights on and keep things moving.
Yeah, so you were working at Mozilla, right?
Mm-hmm. Yeah, no, I was
Okay.
an employee from 2012 to 2020.
And that's when I think the big layoff happened for a lot of people, right?
Yeah, that was when about a quarter of the company was let go, and that included almost all of the sort of the R&D department that covered both Rust and Servo at that point.
Yeah, that was pretty bad thing. I mean, it seems like every couple of years we're due for a huge layoff in tech, and it's sad.
It really is. And
I mean,
definitely that was an event that really took the wind out of Servo's sails at that point. But as I think we'll probably get to in a bit, I think there's hope now. There's been some action recently that's got me really excited.
well, I kind of like to talk about that time a little bit because I haven't talked to anybody who was working at Mozilla at the time that got part of the layoff. And what from the outside, it was like, oh, Rust is dead. It was a lot of, people talking about, but there was a huge change up. It was like scramble. And then I think Rust Foundation got started to try to steer everything. And it's kind of almost better for the community, right? Because there was just too much on Mozilla's hands regarding with Rust.
Yeah, I mean, I think there is some truth to that. It was an interesting time because, back in 2020, Rust had actually established itself by then. It was more than just a Mozilla project. That always had been the goal. The people building Rust were always really keen to have it be more than just another corporate language, and we really believed in the promise of better tools than C++. And everyone should have access to those tools. That's why it was open source. That's why they were aiming for a governance model that wasn't just tied in with being a Mozilla employee. And it's also a reason, one of many reasons why Servo's influence over the project waned over the years. In the beginning, there were a few of us who were working on both Rust and Servo at the same time, and a lot of the decisions that were being made about the language were really heavily influenced by how will this impact building Servo. But again, as more people outside of Mozilla became interested in Rust, it grew to have a core team of non-employees, and there were different language teams and compiler teams and everything. When 2020, when the layoffs in 2020 happened, I mean, I was never worried about the future of Rust when it happened. I already knew that there was solid infrastructure that was being supported by other organizations at that point, I'm pretty sure. So I didn't have any fear that Rust would, wither on the vine at that point. But I can totally believe that people outside, without that perspective, were more fearful about what this meant for the future of the language at the time.
Yeah, I think the part that was kind of like the haters or the people who want to have doubt in this. Kind of like if you look for something, you'll find it, even if it's a hint. We've seen plenty of that the last few years with, I don't want to be political, but I think with Donald Trump, I think that kind of boosted a lot of this kind of stuff. You'll find things in places. My mom's always telling me weird stuff like, oh, do you look at this? If you count these things, it's a weird number. That number is related to, it's, yeah, so not need to be political. It's just sometimes I think people look for things, and if you look for something, you're going to find something, even if it's not related. Reminds me of back in literature class. It's like, oh, his shirt was red. Red means blood. It's like, are you sure he's just not wearing a red shirt just because he's wearing a red shirt? I don't get it. But anyways, yeah, I mean, it's interesting. I think there was always this kind of talk about, okay, we need to do it. But sorry, when I say do it, I mean getting that kind of foundation to kind of make sure it's not all on one
Hmm.
company's head. But I think this was a catalyst to make it go faster, right? It's like, okay, now
Oh,
this is a
yes.
problem, right? Because the big people or some of the bigger people were being let go, right?
No, absolutely. By the time that happened, like I was really focused on like Servo at that point, and like we were just like consumers of Rust. So like I don't really have much insight into like the process of like how Rust got pulled out into like the separate foundation and everything. Like the Servo team was focused on just like getting Servo under the banner of the Linux Foundation and making sure like the trademarks that Mozilla owned at that point could be extracted out. So that's what we were focusing on at that point.
So Servo is web engine, right? It would be kind of comparable to like WebKit.
Yeah, WebKit's actually a really good comparison. We always we try to describe it as like a web rendering engine where you focus on like is responsible for everything that happens like inside of one single tab. And the actual like browser that most people think of would be like a separate set of concerns. You don't need to think about bookmarks or history. You don't need to think about like, you know, how you do like drag and drop for tabs or I don't know, I'm blanking on like other things that make up a browser now, add-ons. At some level, like all those things like interact with the web engine in some way. Like you need to decide like do I turn this link purple if it's been visited before? That's part of your history, but like that's part of the browser. So like where's that distinction lie? But yeah, so Servo is a web rendering engine. We were always focused on like what does it mean to render a single page in a single window and can we just ignore everything else that goes around like that goes on around that?
Well, that's interesting too, because if you compare it to WebKit, so I believe Chrome uses a modified version of WebKit.
Heavily modified.
Yeah, they also have their own JavaScript V8 engine, but you're saying you needed to add JavaScript rendering or JavaScript to Servo, is that right?
Hmm.
So they're actually
Yeah.
they're embedded, right, rather than separate as Chrome is.
So not precisely. So the JavaScript engine is actually sort of a really interesting part of the browser because so it is a huge amount of work to like build a new JavaScript engine. In general, like you might start with an interpreter that like parses your JavaScript into some kind of like easy to execute form after validating that like it's valid JavaScript. But like an interpreter compared to any other browser out there is going to be so slow on like the interesting content. And so inevitably like every engine that cares about speed will end up like building a just-in-time compiler that like goes and actually compiles like snippets of machine code from whatever you end up interpreting and has to make decisions around like what are the parts of the code that like need to be fastest, what are the loops that we can like compile just those little snippets and run them really efficiently, and like that again is like a whole other level of work that needs to be done. And so again, like Servo was being built by a really small team, and so we said, okay, we want to build a browser in Rust. We want to show that it's viable, but like it's not realistic to dedicate all that effort to building a JavaScript compiler in Rust and then also have to deal with like the unsafety of generating machine code and losing many of the things that make Rust useful there. So we took the JavaScript engine from Firefox called SpiderMonkey, which is already again like Chrome and V8 is separate and embeddable. So we took that and my role was integrating that into Servo, building a huge chunk of C++ code and shoving it in there.
Okay, so you still rely on SpiderMonkey. I guess that's not a bad thing. It's better to use something that's well known and well tested than to build your own. But then again, you are building a
Yeah.
whole new web engine, which we have quite a few already, and all of them are quite different. And some of them all share the same lineage, right? Everybody is either pointing back to WebKit or pointing back to Chrome, which is a variation of WebKit.
Yeah, and web came from like KHTML and
Yeah.
that had a history. Yeah, I mean, it all started somewhere.
Yeah. It's kind of like the big media companies. Like there's always like maybe two or three, and then all the other ones come from there.
Yeah. A bit depressing. But yeah, so similar to the way that like in the earlier days, Rust language developers used to talk about how you had like a complexity budget. There was only like so many new things you could shove into a language before people would look at it and be like, oh, nope, I can't do this anymore. I can't like keep learning all these new things. I need like some familiar things to gravitate towards. And so, I mean, in the same way, when you have like a limited number of people working on like a huge greenfield project, you need to figure out what is the value budget? Like, what is the actual useful things we can build that demonstrate that this is like worthwhile versus what is like intellectual curiosity but ultimately doesn't like teach us whether using Rust for this was like improvement over the status quo. So I mean for us that was like the layout engine the HTML
Mm,
parser. There are a number of things where we looked at like where are the parts of other engines that have caused the most trouble in the past? What are the
mm.
areas which have caused the most security vulnerabilities? Can we make those impossible? That was really the ambitious goal we were going for.
No, not just that, but also make it faster too. It's like more secure and faster,
Hmm.
right?
Yes, is always looking for like how can we take advantage of the model that Rust gives us, and can we do like can we lay out pages faster? Can we make more efficient use of like lower power cores on mobile devices, things like that?
Do you know the top issues that Servo team was actually trying to solve? Like, I mean, if you could be more like specific, but not too specific, if that
Hmm.
makes sense. I mean, was it like rendering tables was a problem, or was it just rendering a page in general was just unsafe and an issue?
So rendering wasn't the unsafe one, or to some extent. So in general, we were looking at rendering being slower than necessary, and we believed that we should be able to do more of it in parallel and get benefits that way. And then we were looking at sort of implementations of web technology that in other engines tended to cause security vulnerabilities at worst or just crashes at best. So, an example of that, there were multiple attempts to parallelize the part of rendering a web page called style computation. And that's where you already have your DOM tree, your tree of nodes, and you have your CSS. And you need to figure out, okay, for a given node, what are the styles that actually apply to it? And there's rules in CSS that like specify like given a certain like pattern of nodes in the tree, if there's a certain like sequence of children under a certain root node, then you can choose to apply like these filter color and border properties to this node or whatever. And really, that is a problem which should be embarrassingly parallel. Like everything about it is designed in a way that like it feels like it should be a model problem for describing like how to parallelize a browser engine. There were at least three different attempts in Firefox over the space of like 7 years that I was aware of, where people tried to like retrofit parallelism into Firefox in order to do that and take advantage of multiple cores. And each one was abandoned because the resulting code was just too complex to reason about. It had too many like subtle crashes that needed to be tracked down, and therefore like ultimately it wasn't seen as being worth the investment required to like get the relatively small benefits that people expected out of it. Meanwhile, we built it in Servo from the beginning, and in Servo's model, it was embarrassingly parallel. We just threw like Rayon at it, and effectively, like we got the parallel traversal for free. It's a little bit more complicated than that. Like we spent a bunch of time looking at like how to parallelize these different parts of layout, but like that part of layout in particular worked really well within Servo, which was very satisfying when like the promise of Rust is that if you build within its data model and its constraints, then like the compiler will reward you free parallelism if you just do like parallel iterators or something. So that was one example of one area that like we were really keen to demonstrate Rust was a great investment for things like that. And then similarly, there's a lot of code in like Firefox I'm most familiar with where they do a lot of things on other threads. And you have, pointers to objects that like can only be used on certain threads. And it's full of like assertions of which thread am I actually running on? Am I on like a worker thread? Am I on the main thread? And you need to like send these messages back and forth between them, but it's really easy to just like reach into the object and touch something. Because, the default model for being safe about writing multi-threaded code in C++ is just you have like a mutex inside of a class, and you just need to remember to like lock the mutex before you can access members of that class, which is opposed to Rust model where the standard library has mutexes which actually wrap the data so that the compiler will not allow you to access the data inside the mutex unless you lock it. And so again, tons and tons and tons of crashes within Firefox from all of this handwritten code that like didn't end up like grabbing the mutex correctly before touching something. And those things just like didn't exist at all in Servo by default because it just like wouldn't let us write, invalid multi-threaded code when we were following like the right models. So again, we did an analysis of the like vulnerabilities reported in the web audio code in Firefox over the space of like 5 years or something. And we looked at all of them. We said, okay, you know, realistically, like, could this have happened in a like perfect Rust implementation? Like, could we have encountered the same kinds of crashes and like written this code? And ultimately, I think we decided like 75% of them we believed would have been completely impossible in like the ideal Rust implementation. That like the way that made sense to write the code in an engine like Servo just like would not expose those abilities to cause those errors. And like browsers are a huge target for hackers. There's a competition called Pwn to Own, which happens I think every year, where like some of the highest value targets for revealing new vulnerabilities are web browsers. And so like anything that fundamentally remove these kinds of vulnerabilities from browsers is I think extremely good for like users and good for browser makers. And I think we're starting to see this in like Chrome recently announced that they are going to be integrating like Rust code into the browser like officially as a supported language because they see the value in these kinds of protections.
Yeah, you're starting to remind me. I remember back when everybody was jailbreaking their iPhone many years ago. I don't know why we don't do it anymore, but we just don't see the need. But there was quite a few where you just went to a website and it would help you to jailbreak your phone, which is pretty. I mean, I didn't think too much about it at the time, but it read the resonates now that, like, actually, that's probably bad. That I can go to a website and then my phone is jailbroken. If they can do that, I'm sure they can do much worse than that.
It's a really fascinating ecosystem. Yeah, the risk of going to a website and having it, exploit a vulnerability in your browser. Yeah, it's a bit weird when you think about it.
Well, not even the weird part, right? That kind of makes sense that you can find vulnerabilities in just a lot of stuff. Like I've heard that you can just send a picture to somebody. They don't even need to open it. And then it's like they're taking over. That part's fine. But the other weird part is like, oh, I'm actually like exploiting something that can hurt
Yes.
me. And why is it that I find this good? And people tell me I should be running a certain iOS version, or otherwise I won't get all these goodies. It's like that sounds scary because if this guy knows how to use it for good, then somebody knows how to use it for bad, right?
Oh yeah. Working in browsers is a really fascinating space. Like I really enjoyed my time doing it. And yeah, the kinds of so as someone who ended up spending a lot of time working on like the JavaScript integration in Servo, the code that gets run, especially like code that is generated by fuzzers. There's like a few people in the community who were just like really keen on Servo. I don't know what sort of if they did anything with it, but they would just like run fuzzers against it occasionally and would like submit bug reports. And like the JavaScript that gets executed in those things, very, very weird. Like nothing I would ever write by hand, but it would always expose like surprising bugs in like the way that the engine was integrated in Servo with like mashing C++ with Rust code was always sort of my less clean code I've ever written in my life.
Yeah, I've done a little bit of FFI. You don't feel good when you write the word unsafe. You feel dirty, but then you have to sometimes use unsafe. Even in the safest of Rust code, you still need to sometimes do that. If you look underneath some of these common methods or functions, you'll see that they may be
Mhm.
using unsafe underneath. Even though it may be safe, it's just like, well, no matter what, you're going to have to write unsafe because the rules of unsafe are going to allow it, but normal safe Rust will not allow it.
So I think I got better as the years went on about like documenting why something that was marked as unsafe like should actually be safe. Which then, made it easier when I'd come back to it like a year later when something was crashing inside it. I go, oh, okay, so it wasn't safe for this particular edge case. How does this change how I feel about this now?
I mean, so it was on the boundaries between going to Rust to C++ or to C rather than in C or C++ itself.
It depended. Sometimes it would be things like the JavaScript engine does a lot of things in the background. It has worker threads. It allows like off main thread compilation. So you say, okay, I have this long script that I want to execute, but I don't want to tie up the main thread, compiling like 500 kilobytes of minified JavaScript code that's all like bundled together. So please go compile in the background and then like notify me when, you're done compiling. And so it's got its own thread stuff going on. It sends you like the engine ends up like you give it a function callback and it passes this like pointer which represents this like value that can be sent between threads, but like Rust doesn't trust that, so you need to like wrap that in a structure. And basically, there were like things where the lifetimes of values you sent to the C++ code were not always clear, like how long they need to live for. Like if you send it a pointer to some source code that gets executed, like where does it actually make a copy of that internally, or does it refer to the original code, like refer to the original text, and so you need to ensure that lives long enough for the compilation to succeed. Those are like the weird edge cases there.
Okay. Yeah, I mean, I'd kind of like to talk about because we started on this topic, but I don't think we really finished it out, like the topic of when Servo was being worked on. So Servo was kind of like what do you call that? The test I would say as an outside person, it was like a test project that was kind of proving that you can build serious software with Rust. That was my outside perspective. That may not
Mm.
be what the truth is, but even you were saying, okay, Servo was kind of serving as a way to test out stuff in Rust to make sure that you're going the right way, or to kind of guide Rust. Is that true?
Hmm. Yeah, there are a few things going on there. It started as both a demonstration that Rust was going to be able to achieve its goals, and therefore we invest time in building on top of like Rust technologies. Like early on in like 2012, 2013, Rust supported what are called green threads, and we were building really heavily on that and like making measurements showing like how it impacted our work. And then at some point, the Rust project that like most projects that were not servo like didn't actually want green threads, and they really wanted finer control over like native threads. And so like then we had to adapt to that change once they got rid of them. So servo was really like it was both a demonstration, like you said, a test bed, but also we were really building it in a way that even if we didn't end up building like an entire complete browser, we wanted like certain parts of it to be extracted. And so we always wanted a relationship with Firefox where like parts of Servo that were like really like demonstrated their success could be extracted and slotted into Firefox. And that did happen. The style computation that I talked about previously, where like we successfully were able to parallelize it, where Firefox had not, like that got integrated. There was a whole team that worked on that. A bunch of the rendering code in Servo that was doing things in parallel and like really heavily focused on the GPU, like that got extracted and put into Firefox as well. So like in that sense, I think Servo was very successful in, creating things that were used, even if it didn't turn into a full browser during that time. But we on the Servo team, we were always looking for like what else we could do that wouldn't necessarily require like building an entire browser for like anyone else could use it, because that is always like an enormous prospect. Not only is it like an enormous project by itself, but like what constitutes a complete browser is always changing because like web standards continue, like new ones are created, the older ones continue evolving. Like the browser landscape is very dynamic and alive. But we were always a relatively small team of like sort of research focused people. We were looking for opportunities to make Servo embeddable in environments where you didn't necessarily need to be able to render the entire web. And so, as of around like 2018, I think it was, we sort of pivoted away from focusing on main desktop web that we'd been looking at for a while to focusing on like virtual reality and augmented reality devices. And that was really neat because the kind of web content that those devices cared about at that time was really like most important was the 3D content. So as long as we had a good WebGL implementation, and then we started implementing the new experimental specifications around VR and AR, then we could actually go a long ways to doing like cool things with the engine in new platforms that like were useful to people and weren't just people always saying, "Oh, but you can't render Gmail, so why do I care?"
Okay, that makes sense. Yeah, I mean, there's web has become well, it's been like this for a while, right? Like a way to develop user interfaces in a somewhat easy way because nearly most programmers at the beginning know HTML, right?
Mhm.
And so there's
Mhm.
a lot more, like even in Rust, I think the most popular GUI library I think I've seen is probably the Tory, or at least to make apps. And that
Yeah,
one uses,
it does seem
yeah.
really popular as a way to, especially as the GUI story in Rust continues to be sort of not settled yet. It does seem like the easiest thing for build on.
Yeah, so it's also interesting to hear that. I like the fact that it's not like an all-in situation with Servo. Like you said, that it's always had the idea that okay, we can take the parts that are ready and passing and stick those into, or let them be. I don't know what would you even call that. Like let them be extractable. Is that? I think that's the term that you used.
We were really aiming for like a modular engine. So like
Yeah.
I think our HTML parser has been really successful. It exists as an independent crate. It exists in its own repository, and there's a bunch of different like crates that like rely on it to do like higher level functionality of like scraping websites or whatever. So like those sorts of success stories make me really happy of like technology we built that like the community gets to rely upon.
Yeah, that's actually interesting too, because I wanted to talk about that one. I think the parts of Servo have already been in Firefox for quite a few years, but maybe not everybody knows that, right? Like you
Yeah.
said, parts of the CSS renderer and things like that. I remember I heard that and I pulled it in and I was like, ooh, okay. I don't really I was like, I think I kind of told myself that I was feeling something different, but I don't know if in reality there was really a difference. Maybe for some very complicated websites, there might be a difference. If I had side by side comparison, maybe I could tell the difference. But that was actually another question I had was like, the part that is difficult for me to understand, it's like, when should an issue be solved upstream rather than downstream? If that makes sense, that kind of question. Like, okay, I got this problem in my browser. I could fix it in, let's take the parsing of CSS in there. Or, I have the result at the end and I know the case and I could just change it at the end. Like, how do I know when would be good and when should I fix it and where and which part? Because like you said before, like even when you're describing Servo, it's like, well, is the JavaScript engine part of Servo, or is it something that's embeddable, or is it something that is an outside service that I kind of hook into? Where does the edges of responsibility kind of lie?
Yeah, I mean, I think one of the advantages of the browser is, in many respects, like when you're building a web rendering engine, like so much of what you're actually building, like there's a specification for it. We're at a point like where a ton of work has been done by people building out the web landscape to identify like common behaviors between browsers and then write it down as like these are the steps you should be following if you're building like a new thing that is supposed to be compatible with other browsers. And like the Servo team was part of that effort. We did a lot of work to take underspecified parts. As we were one of the first like new implementations in a while, we were able to read through a lot of these specifications and say, okay, this doesn't actually make sense from the perspective of someone who doesn't already have an engine. It's very difficult to like follow what is supposed to be happening here. And so we did a lot of work like up and down the stack of trying to figure out, okay, when something it behaves differently in Servo than Firefox, like where does the problem lie? Like, does our implementation match the specification? Does the specification seem to suggest that like the result we're getting is correct? Is it a bug in Firefox? How does it look in Chrome? And like when you get like 2 out of 3 browsers that agree, then you need to figure out like, okay, should the specification be changed or should the like one browser disagrees be changed? When you have 3 browsers that disagree, you're like, well, all bets are off now. Like something's got to change, but who knows what? So like there was a lot of that kind of work where we'd either go like, okay, we have like a bug in our like CSS parser, or there's specification is underspecified or something. But I don't know, there's a number of people in the community who would take part in that who seem to find it really satisfying to find sort of edge cases in the specification like that, and then like help make the specification better for everybody and add a little test for it that would be run against all the browsers. I think it's a really neat like collaborative environment to be part of.
We had a previous guest on here that talked about specifications. I can't remember who exactly it was, so I'm not going to name which person because I can't remember who it was because two people in my mind. But there's always this issue of like, okay, the specification, the spec says this, and sometimes they use the word should, and should is not actually binding, right? And then, like you said, there's this kind of informal agreement that, okay, we're going to do this. Like you said, you look at browsers and see how they implement it. And like you said, 2 out of 3 or 3 out of 3 do it. So obviously you should do it. But then, like you said, if there's 3 out of 3 with different ideas, then, you just kind of choose something that makes sense to whoever has to be in charge of that. And then that's what you do, right?
Yeah, I mean, there's a lot of like working with people from other browsers to say, hey, listen, if we make this change to the specification, like, can we actually expect like other browsers to change to match it? Specification only matters as much as implementations actually follow it. And there's a lot of goodwill in, but it is sad. It's a sad state of affairs when a specification has been updated and like the browsers don't actually like make the corresponding change, because then it gets confusing for web authors who try to say, well, the specification says it should be this, but this browser shows this result instead.
That's why I'm very happy that caniuse.com. It's been helpful as a web developer where you can see and then you
Hmm.
can kind of figure out, like, because sometimes things are working in Safari, but not in mobile Safari. And you're like,
Yep.
well, how many people are actually going to be using this on the web or on their mobile phone and etc.
Yeah, efforts like that have been absolutely huge. I think it's really important to have that kind of like realistic information for web developers.
Yeah. And also it kind of gives you caveats like, okay, this part of the spec has been done, but not this part being done, or it's an
Yes.
experimental or whatever. So that's also interesting. The annoying thing is the browser, what do you call that? The browser prefix, where it's like dash WebKit,
Mm.
whatever. Those are really annoying for the CSS, but I understand it's like we know what something's going to be there, but we're not quite sure exactly what that will be and what the names are, right?
Yeah, I do think like Working in the land of web standards is fascinating for that reason. You have so little control over like what users can actually do and what versions people will be using and like when things get implemented. It's very much like a best effort, assume good faith on the part of everybody involved.
What I think is the most interesting, I was just looking at Can I Use, and I looked at the CSS Grid layout, and it's funny that basically everybody supports it. Partial support with IE11, right? But I think everybody moved on to Edge, hopefully. But the funny thing is that Opera Minis doesn't support it at all, which is kind of interesting. It's funny to see some of these things that you think are actually normal, and then you look at it and you're like,
Yeah.
wait a minute, how come this guy doesn't support it at all? What's going on over here?
And there's no grid support in Servo yet either.
Oh, now that's just sad because that's pretty powerful. Like that's probably like I think the number one CSS like invention in the last 20 years to me at least is like
Mm,
is Flex. Number 2 or 3 or 4 probably would be Grid because it's so much more powerful, but if you have Flex, you can basically do most stuff you can with Grid, just longer.
yeah. We have a partial Flexbox implementation, but like layouts really like the Achilles heel of Servo through all the years, where like it requires a ton of work. It the people who have the experience necessary to like do that work are more or less already employed building browsers. And so it's a very difficult problem to crack of like building a layout engine from scratch that can actually render like real complex websites because you're interpreting like really complicated CSS specifications and figuring out, okay, now how does this fit into this engine that we have designed? And there's many edge cases that are underspecified. And so, yeah, that was really one of the reasons why I think it was difficult for Servo to find a place over the years, was because the thing that people want most out of their web browser is to open up a web page and see that it like looks correct. Because like it can run all the JavaScript you want, but if the things aren't actually in the right position, or like you can't scroll the page because it's got like funky layout or something, then it isn't actually super useful to users. And that was really one of the benefits of pivoting to like the VR AR stuff late in Servo's life at Mozilla was that had fewer, or it gave us more runway for working on layout things because the actual requirements of the websites containing 3D content was pretty minimal. So we could get by with like partially implemented layout engine. But a thing that I'm really excited to share is like there's now a group of people at Igalia who are they're funded to work on Servo's layout engine and really drive progress there. And like the area of the browser which is most challenging to get the wider community involved in because of these like niche skill requirements. But like they have years of experience of working on layout engines, and I'm really excited to see some progress from them over the next few months, hopefully.
Now, I did have a question that popped up as you were talking, right? We're talking about the browser support, and you said a piece of the CSS rendering is already in Firefox, but then you mentioned that Grid is not supported, but of course I can see Firefox Grid is supported. So we're kind of like, where's the boundary of this? Because obviously it seems, like you said, layout's kind of a problem with Servo. People are working on that. So is it that just the parsing of CSS is done within Servo, or that Servo piece, or that REST piece, or whatever you want to call it, and then hand it back to Firefox to actually apply everything? Or
It's a good question. So layout has like a couple phases. Basically, sort of like three main phases. So one is the style computation bit, which I mentioned earlier. That's where you have your DOM tree, you have your CSS rules, and you need to figure out like what rules map to which nodes. So that is code which is largely independent of the actual like whether support for layout for laying out a particular like kind of CSS content is supported. Because that's really just saying here's a node, does it match a certain like pattern of known rules in CSS? Like that was written in Servo. It's on the code under like components/style, I believe, in the Servo repository, and that just deals with like there's a little thread pool that has like a collection of like nodes that need to be styled, and just like keeps grabbing new ones from there and like checking against these style rules that it knows about. So once you actually have computed the style for your tree, then what most of us think of as like layout code at that point is then responsible for saying, okay, so given I have this node here and it has these siblings, like how big are their boxes? What background color is it? What text lies inside this? What are the like the border styles for this? Is there a shadow? All those things, and then figuring out like how does that actually translate into like the actual graphical representation that you see on your screen, which has its own C++ implementation in Firefox, which hasn't been replaced, and which we're slowly chipping away at writing like an equivalent Rust implementation in Servo. And then meanwhile, both Firefox and Servo use the same rendering part, where that rendering part is called web render, and it takes what's called a display list, which is like a list of basically rectangle and border and like border styles and things like that. The things that represent like visual elements in a web page, like really like primitive forms of them, and say, okay, this web page is made up of these different elements of display items. Please draw them as fast as possible. So it's the layout bit is the bit in the middle that takes those styled nodes and figures out how those turn into like display items and sends those to web render. And that's the bit which has like a grid implementation and a flexbox implementation and I don't know, all the other parts of CSS that turn into some sort of visual element.
Yeah, that the CSS rules are crazy annoying because you have the outside external CSS sheets, and you have multiples of those, and they can override each other.
Hmm.
And also, even in the same sheet, it's like precedence. So if you have a bunch of like, how would you call that? The descendants, right? If you start naming classes and classes and classes, not just combined, but like,
Yep.
well, it's also combined, and there's different priority on those. And then you also have, of course, inline at the top and the head, I think. And then you also have, or is it called inline that's on the message?
Yes, the inline styles
Or
from
sorry,
like
on the
the style
node.
attribute.
Yeah, sorry, inline on there. And but what is the one at the top? Is that called embedded? I forgot now.
I also don't remember.
I thought it was called inline, but yeah, it makes sense for it to be on the node. And yeah, like I said, all these things got precedence. Oh my God, like to combine all this stuff and to calculate the rules is crazy difficult. Like, I don't know, whoever worked on that. You said you worked on that, right?
I didn't spend a lot of time working on the like CSS and layout parts of the engine over the years. I think my focus has always been mainly on the like JavaScript integration, um, sort of like JS API, like implementing the APIs that JavaScript can call into, as well as for a while I was really interested in supporting like developer tools in Servo. And actually that's a fun one because we went about it a really like interesting way. Rather than so the context here is like developer tools in a browser is really helpful for being able to like pick out an element and figure out like what is its border size, its like margin stuff, and like changing styles on it, like playing around with the page and figuring out like if my page looks wrong, like why does it look wrong? So we wanted to be able to make use of that in Servo as well, but like we didn't have a full browser and we didn't want to like reinvent all of the developer tools from your favorite browser because that's again a ton of work and not necessarily like interesting work. So what we actually did was because Firefox is built where the developer tools run in like one process whereas the actual web content in another process, it also supports like connecting the developer tools on your laptop to like Firefox running on your phone, called remote developer tools. And so we realized, oh, if we just implement the developer tools server in Servo that can talk to the Firefox developer tools front end, we can get all the benefits of the existing developer tools in Firefox without having to build any of them. We just have to speak the same like network protocol and pretend that we're Firefox. That is how we got a JavaScript console, and we got a like layout inspector and a network panel that would show like all the network requests being made. I was very proud of that. I built the first implementation of that on like a train ride where I was a bit bored.
Wait, I was just thinking as you were saying, pretend that you're Firefox. Doesn't every browser pretend that they're Firefox? I believe it's like in the user agent.
Yeah, it's really depressing how many different like browser names are present in every single browser user agent.
And everybody says, oh yeah, we're using Gecko. Because I remember that history. It's like, what?
It is so depressing. User agent sniffing is a curse.
And then you make sure that you have to ignore I just remember now about all the baggage from years ago. You have to ignore the comments that says that if you're not IE less than 7 or whatever. The
Yes.
baggage of web is insane.
There's so many subtleties around backwards compatibility there. Yeah.
That's the crazy part is I remember watching this video, I think it's Computer File, and I think one of the guys was talking about how the browser is one of the most forgiving like parsers out there because like number one, there's just so much history that you have to support. Websites just cannot stop working one day, something like that. And then two is that you need to forgive mistakes. Three is that you have so many standards, right? Remember, yeah, HTML5 probably is the most popular one that people know. There's also XHTML and then lots of other ones, and then there's different revisions of those on the doc type.
Yeah. it was really fascinating because we had a really fun mix of people working on Servo, where there were some people who didn't have like a ton of like experience building web engines. They came from a background of like optimizing code to be as fast as possible. That whole mindset. And then we also had some people who had been working on like other web engines for like years at that point. And they were in the mindset of like the most important thing is backwards compatibility. Like you cannot break existing web content. If you break web content, like you have to revert it because like you can't ship it. And so there's always this really fascinating tension as we were building this new engine where like one of the people on the team who's like really focused on, demonstrating that this particular benchmark can be like 4 times faster if we just like notice this one particular case that we can skip and then like avoid a lot of wasted work. And he'd like make a pull request and then we'd be like, oh, that's really exciting, let's merge it. And then the next day the person who's like really focused on backwards compatibility would take a look. He's like, nope, here are these 3 reasons why this will break. Like here's an example of a site this will break, we must revert this. So it was always found that tension to be really interesting where you're always looking for like what's the best we can do within this like really broad and like frustrating set of constraints occasionally.
There's so many reminders in this episode. I'm sorry. For another podcast, I did an episode with one of the creators of Dart, who did also the V8 engine for Chrome. He told me about this specific feature that they had called de-optimization. Because like we talked about before, how you just got to optimize and try to, make it faster. But what they found out was kind of similar to what you guys are talking about, but how do you say it? Because JavaScript's such a dynamic language that it's hard to kind of compile it because you're going to you may hit an edge case later where what you've optimized for actually doesn't work. So they built in something called a de-optimizer, which will actually roll back optimizations that no longer will work in certain implementations. So it's kind of similar. It's like, you want to always optimize like the one person. But then once you have an edge case, which you can't run the optimization anymore, you have to somehow roll back. And sadly, that person has to roll back all that optimized code. But it's not like the other one where you can roll back the de-optimized from the JIT, which is what they were talking about.
Yeah, we spent a lot of time looking for like patterns that we could make assumptions about. So like, one thing we were looking at was, are there certain like forms of layout where we can like we're guaranteed that there's no way of interacting with other parts of the page within a certain area. And when that's the case, like you can absolutely go to town and parallelize that layout. Like I think Wikipedia is a really great example, or maybe like mobile Wikipedia, but like there are some layouts that just use these like really self-contained boxes and have like a bunch of these. And those really should be like the ideal case for speeding up layout. If you can just like throw as many cores as you want at that problem. And similarly, we were looking really early on. We built the ability to run like iframes within pages, first in independent threads and then in independent processes as well, because we realized, okay, the actual boundary, like rendering content can't escape the iframe, and there's a really well-defined boundary of, in many cases, of like what the JavaScript is allowed to do to like reach up out of itself into its parent. And particularly if they're cross-origin, then there's like a really limited set of things they're allowed to do. And so that, again, like that's one of those cases where it made a lot of sense. As a new engine, we had a advantage of just being able to like spin up a new thread and start a new JavaScript environment in that thread and run both those pages independently and get a lot of like benefit that way. Because then would allow something that we could do before many other browsers was being able to have like one iframe which was being like doing like really CPU intensive work. Whether it's just like, you could imagine like poorly behaved ad or something that's actually like calculating a bunch of like intense mathematical things. And in Firefox at the time when we built this, it would mean that like the outer page that contained this iframe would like lock up every time the like the child iframe was like doing this really CPU intensive stuff. But in Servo, we would have both of them running like completely fluidly without interfering with each other, and that was a very satisfying thing to encounter.
I'm just thinking to myself how difficult it must be to work on Servo. You want to be fast, but you want to be correct, and you want to have backwards compatibility. And I don't know how it's so difficult to imagine all these. The one thing is that every programmer wants constraints, but for once, I actually feel this is too many constraints.
It would definitely be a very different project if you could break all backwards compatibility and do whatever you wanted. Although it's interesting, you should mention like how hard it would be to work on Servo, because like I think certainly there are some parts of the browser where I think that is true. I think layout's one of those areas that historically that's been the case. But one of the things that like I really loved about Servo and like continues to still be true to some extent is I think we got a huge boost by being a Rust project that like had a lot of interest when Rust was in its early days. And there was a surprisingly large community of people who were making like significant contributions to the browser. And I think that was true for a number of reasons. Because the promise of Rust has always been that it gives you more power, but it also like it holds your hand. So like you can make fewer mistakes by using it. And I think that made like Servo feel more approachable to many people because it was smaller than other browser engines, so there was like it was easier to understand in many ways. It was a like exciting new language that people were really curious about, like what does Rust look like at scale, what does like a significant large project look like in this new language. And we had a number of people on the team, including myself, who were really keen on actually doing the like mentoring and bringing in new people and saying, here, listen, there's this JavaScript API, which is like, it's really well defined in the standard here. You can read the specification and follow along. And if you've got any questions about what it takes to actually implement it in Servo, like I'm happy to help out. But this is absolutely something that you could take on as someone who's just like interested in Rust and has written some like programs on your own. I think Servo is probably the most approachable like web engine out there for someone who's interested in the platform or interested in Rust and would like interesting learning experience.
We're approaching the end of our time, but I would kind of like to talk a little bit about what is the current part of Servo, right? So Servo, I think, was largely funded by Mozilla before. Now it sounds like maybe not so much anymore, but you're still getting help, outside financial help. Are you actually working full time on Servo, or what's kind of the
I'm
status of
not.
Servo? Hmm.
No, so I'm not part of the team that's working on it full time. For the past couple of years since being laid off from Mozilla, I've been continuing to like keep the lights on the project and make significant changes occasionally and help out when people have changes they want to get reviewed. But so my role right now as there is a group of people working on it full time is sort of an advisory capacity and helping ensure that like our infrastructure is working and giving advice on, hey, we encountered this problem, you should probably know about it, things like that. But yeah, like there is a project fund which we use occasionally to like we're talking about how we can bring on more people to spend like more full time on this work because browsers really do require like dedicated time in order to make progress. But I personally am not working full time on it.
Okay. And it's got a whole like consortium that's working together from people from different companies. You have a couple people working full time doing pieces of it, I guess, from outside funding from outside companies. Well, when I say outside Mozilla, is there anybody at Mozilla still working on Servo, or because I think their strategy has kind of shifted since the layoffs, right?
Yeah, I'm not aware of anyone employed at Mozilla with the like intention of working on Servo. There are there's at least one member of the technical steering committee for Servo, which is like this official sort of group of people who help guide the technical future of it, who does work on Firefox and helps with some of the like syncing code back and forth between the two projects from those shared bits which I mentioned, like the style and the rendering code. So like there's still some of that going on. But I think Servo has largely moved away from like Mozilla's future at this point, and we're sort of forging our own path at this now.
Okay.
And I think that path really at this point is focused on our goal at this point is demonstrating viability. Like if we can get to the point where we can render like a small set of websites and web technologies consistently, we really would like to get to the point where Servo is considered like viable for like embedding in other small projects. We want to get people excited about the ability to take a Rust project and put a web rendering engine in it in order to maybe you're displaying like a GUI or something. Maybe you're displaying like a very limited set of web content that you control what's in it. So you don't care so much about like arbitrary sites like Gmail or I don't know, YouTube or something. I think once we reach that milestone, it'll be easier to then get other people involved and get other like companies excited about like the prospect of Servo as a safer embeddable alternative to the web engines that exist today.
Okay. I mean, I'm happy that everything's going to keep moving and you guys have goals and everything. I think, yeah, I mean, it's good to hear what's going on with Servo because it's just been quiet.
Hmm.
And I'm happy to hear that's still moving on and there's still goals. And the pivot to AR VR is quite surprising, but Not so much because there's been a huge push from Meta, etc. They're saying, oh yeah, I'm guessing like what I've seen is like you have like this, I don't know, you can have a Zoom call within the metaverse, which I thought was a little bit strange, but it's interesting.
I will say, Servo shipped in a product. It was part of, or I mean, it was the engine in Firefox Reality, which shipped in the HoloLens 2 App Store. And that was a very exciting thing for us. It was a real living product for like 6 months before the layoffs happened.
All right. And with that, thank you for giving us the up to date what's going on with Servo, what happened since the layoffs, and where it's going and where it's been and what it's doing at the moment and all that. I really appreciate it.
If you want to keep on top of it in the future, check out blog.servo.org or the Servo Dev Twitter account. That's where the updates will keep coming in.
So today we finally implemented Flex or Grid in Servo. We're going to see something like that on the Twitter account.
One day you'll see it, yeah.
Can't wait. That's been a godsend for me, for somebody who done websites back when IE6 was a big deal.
Oh boy. Yeah, we've come a long way.
Let's never talk about IE6 ever again, please. Too many bad memories. I was in China, so IE6 was a big deal for a long time.
I bet.
Yeah, I remember when we had to fake out placeholder with a JavaScript library and everything else. That was not fun. Okay.
The bad old days.
At least you called the bad old days. Usually people call it good old days, but obviously don't mean that. At least you're honest. Okay. And again, with that, thank you for coming on. And then also, if anybody wants to get in contact with you or anything, do you have any way for them to reach out to you directly?
Yes, jdm@servo.org will go to my inbox.
Okay. And with that, thank you for your time, and hope Servo keeps going on, and maybe we'll all be Servo-based in the future, since Chrome is also looking at using Rust.
I, for one, welcome our Servo overlords.